Your voice is not. I'm not able to hear your voice.
Yes, yes, yes. I was on mute. I'm starting the recording. I will start now. Okay. So since it's live streaming and the other introduction, we'll again do it separately. Where I work and all those things, we'll do it in the end. Okay.
Okay.
Let me share my screen and let's talk about business analytics course in a little bit of detail. Okay. So far, what all you have seen in business analytics. Is my screen visible, by the way? And Naman, if you message, I won't be able to see because I'm writing. I don't have access to chat here. Okay. So far, what all we have seen in the first week, we saw about visualization, right? And then we went to a little bit of statistics. We saw chi-square, test of independence. No, it was goodness of it. We saw uniform, Poisson, and so on. And then we got into a little bit of what? Simple linear regression, then multiple linear regression. So here we saw about demand response curve. Then we saw logistic regression. Okay. And then in the coming weeks, we are going to get into few topics, which are data envelopment analysis and conjoint analysis. Right. So in the first weeks, we saw a little bit of visualization. Then we went into statistics, like goodness of it, test of independence, and so on. And then we got into a little bit of prediction. This is where our prediction started. We are talking about supervised learning in detail, simple linear regression, multiple linear regression, logistic regression, and then this is prescriptive analytics. What is prescriptive analytics? Any idea? We make recommendations. So what could be the, for example, in demand response curve, we saw about optimal pricing. What is the optimal price for a product? You cannot overprice a product, underprice a product. So what is the optimal pricing? So pricing problems. So similarly, we have different business units. Which units are efficient? Which units are not? If a business unit is not efficient, how will you make it efficient, and so on, right? So these come under the umbrella of prescriptive analytics. Right? This is how the entire course is structured. Any doubts so far?
No
Okay.
doubts here.
Okay. So it is slightly difficult for me because I'm not seeing a lot of students here. Just a second. Okay. So far, only 3 of us are here. Okay, that's fine. Let's continue with our topics for discussion today. Okay. We will start with a demo of a machine learning model. Okay. So I'm going to talk about certain things that will be helpful for you during your job search, during your internship search, and so on. How many of you know this data set called Iris? Iris data set?
Yeah, I know. I know. Yes.
Okay. So this is the Iris data set, right? You have 3 types of flowers: versicolor, setosa, and virginica. Right? You have the features are in the form of sepal and petal. You have the length and width of sepal and petal. And with this, we might have to classify whether the description denotes to a versicolor or setosa or virginica and so on. Okay, that's the data set. I'm going to show a quick demo of something that you may not have seen before. Okay, I'm loading this data set. Okay, this is inbuilt in this particular library. It is available under sklearn.datasets. Okay, a familiar data set, and the features we have are the sepal length, width, petal length, and width. Okay, this is our data frame. I mean the input features: length, width of sepal and petal. Okay. Any questions?
No, sir.
Okay. Okay. And we have a target variable 0, 1, and 2. What is 0? What is 1? What is 2? Versicolor, setosa, and virginica. Okay. 0, 1, and 2. Clear so far?
Yeah.
Yeah.
Anybody has joined? Okay. Only 3. Yeah. That's fine. It's fine. Okay. So as usual, we will use some packages, standard packages under sklearn, importing linear regression and train test split. Okay. So I'm splitting data into train and test. Okay. I'm going to use this test for a different purpose. So therefore, I'm uh, converting it to a CSV file, and that is going to come here. Okay, so we already have x underscore test that is available here. Can you see this here? I just wrote it for a reason. We will see why it is needed. Okay, I've just downloaded x underscore test. So have you heard of this term called pickle file before?
No, I have not heard.
Okay. So it is something new. I'm happy that I'm bringing a new topic here. So I'm going to import this thing called pickle file. We'll see how pickle file is useful for many ways. Okay. I'm going to use the same linear regression model. So I told you that it is a multi-class problem, right? Iris, versicolor, setosa, virginica. Is this a regression problem or a classification problem?
Classification.
It's a classification problem. But here I'm going to use linear regression. Because this is just a demo video, therefore do not pay attention to methodology or modeling. Just look at the output and then tell me whether this was useful or not. Okay. For now, consider this as a linear regression problem. Do not consider this as a classification problem, because our objective is not to do model building. It is for some other purpose, which we will see in a couple of minutes. Okay. So the moment I did this, we are going to get something here. Watch out for that. Do you see something here? Lin underscore reg underscore model dot pkl. What is this? I have built the model here. This is my model, lin underscore reg. And whatever model we have built, I'm storing it as a pickle file. So far, any doubts so far? Any doubts so far?
No.
Okay. Let us download this pickle file. Okay. I'm going to download this. Right. It's going to, let's open this file. Okay. Let's open it with Notepad. Can you see, can you understand anything from this? Nothing, right? You cannot understand anything. That's a pickle file. You will not open a pickle file whenever you see a pickle file. It is not in an understandable format. But what is this pickle file? Let's go to this particular new notebook. Okay. And here I'm not training any model. Do you see any training happening here? Am I doing train test split? Am I doing training? Am I building linear
No,
regression? Nothing, right? What
Yeah.
I'm going to do is I'm going to just upload. Okay, just a second. It is getting connected. I'm going to upload that pickle file that we had recently downloaded, and also I'm going to upload the X test. Okay. So now what is happening? I'm importing packages as usual, right? I'm opening the file, right? I'm reading the pickle file. This RB is read only binary. That is what this RB stands for. Now I'm directly predicting on X test using this pickle file. I did not do linear regression model building. I've just used the pickle file and then I'm predicting on X test. So pickle is useful here. You don't have to train the model every time. If you train a model, you can store it as a pickle file, use it for predictions whenever you want. You don't have to train the model every time. Is it clear?
So it's a set of predictions, like a set of rules. Pickle
No.
file.
No, not rules. Whatever model you are building here,
Mm-hmm.
it gets stored in pickle
Okay.
file.
Okay.
Okay. So whatever model you're doing, is fitting in all those things, it gets stored in the pickle file, and you can use it for later purposes. You can save a lot of time with this. Okay, so here also you can do the predictions. Now I'm going to install a new app called Gradio. Have you heard of this app, Gradio? Okay, that's fine. It's a UI tool. You can, let's see what Gradio is able to do for us. I'm just running this file and an URL will be generated here. Okay, it is ready. So you see a URL here. You click on this URL. We'll go through the code a little bit later. Now just look at the output that we have got. Okay, so there is sepal length, width, petal length, and width. Okay, you can play with this slider, right? You can increase or decrease, and then give submit here. Your prediction is going to be coming here. You see Setosa here.
Yeah.
Similarly, you can increase or decreasing, and then make another prediction. It will be something else. Right? What did we do? We built a simple linear regression model. We stored the model in a pickle file. And after storing it in a pickle file, what happened? Did anybody drop?
No, sir.
Okay. Or did anyone join? No. I keep
No.
getting some sounds. Okay. So that's why I'm.
Okay.
All right. So what did we do? We stored the model in a pickle file, and then we are again opening the pickle file, and then we write a function to make the predictions, right? And then this is the slider. So if you see the minimum value and maximum value, this is 4 to 8. This is 2 to 4.5, 1 to 7, 0.1 to 2.5. You see those values will be here. 4 to 8, 2 to 4.5, 1 to 7, 0.1 to 2.5, and so on. All those inputs are given here. Don't worry about the code. You can use all the AI tools that are available, Chat GPT and so on. That will going to explain you the. I'm going to share this code with you after this class. You can play with this. You can build UI for other projects. So it is much better than presenting some Excel file. Generally, now if what you're doing when you're making predictions, you provide your output or provide your predictions in the form of Excel or something. So this is much better than presenting as an Excel file. Okay, it's going to give you a lot of brownie points during your interviews and so on. All right. Any doubts? Can we move on?
Yes.
Okay. All right. So next, let us get into classification problem. Okay. So what is classification? That's the topic of today's class.
So that's either it is spam or not email class. Given
So
set of data, you group them.
that is your
So
target variable is categorical in nature. Right. So spam or not, that is a binary classification problem. You can have 3 classes, you can have multiple classes, 5, 6, 7, as many classes as possible, right? And have you heard of this term called activation function? Right? There are a lot of activation functions. Some of the famous ones are sigmoid, softmax, relu, leakage relu, and so on, right?
Sigma we have used, but I don't
Yes,
know why
yes,
it
yes.
is used. Yeah.
Okay, we will see that today. Okay, so let's understand classification a little more, and then we'll do. Okay, so let us say you have a problem where you want to predict the person will pass or fail in the business analytics course. P stands for pass, F stands for fail. So I have to train you for the exam. I also have to give you knowledge about classification. We'll try to do a mix of both. Okay, so only talking about classification, giving you more and more gyan will make you understand classification, but it might not be helpful in the exam. So only talking from the exam point of view may not be also useful, because you also want to go for interviews, you want to get jobs, you want to do higher studies. So we'll do a mix of both. Okay. So P stands for pass, F stands for fail. This is your actual data, and you have a predicted data. Okay. You are building a model, logistic regression model, and you are getting P, F, F, right? These are your predictions. So your actual is pass, your prediction is also pass. How will you tag it? What is it? What is this called? Actual is pass, prediction is also pass. What is this called? Do you want a clue? True, negative, true, positive, false, negative. Hello?
Thinking, sir.
So this is actual is pass, prediction is also pass. This is called true positive. Okay. So similarly, this is also true positive. This is also true positive. Actual is fail. Actual is pass, but you predict it as fail. What is this called?
True negative.
No. Fail is true negative.
It's a fail is true negative. Yes.
Pass is true positive. Actual is fail, but you wrongly predict it as pass. What is this called? False positive.
False positive.
Okay, this is true negative, and actual is fail. You predict it as pass. It is false positive.
False positive.
This is false positive.
False positive. This is true positive.
True positive. What is this?
This one will be true negative.
Yes, true negative. So how many true positives are there?
4.
Oh, 4. There are true positives. How many true negatives?
3.
2, I guess. 3. Yeah.
3.
3 true negatives. How many false positives?
3.
False negative is
0.
false negative is 0. No, not possible. This is false negative. No. Wait. False negative. This is false negative. So actual is pass. You predict it as negative. You predict it as fail. This is 1. I have to reduce somewhere. I think it is. What was this before? 4. True negative is.
This was true negative.
Yeah. This is 2. So total, how many we have? We
9.
have 10. We have 10 observations. Everything is classified as true positive, true negative, false positive,
10.
false negative.
Yes.
Okay. So what is accuracy here? So there are many ways to remember the formula. Some people remember the formula, and then from formula they will give me the definition, right? So the standard formula is true positive by true negative by everything. True positive plus true negative plus false positive plus false negative, right? So if you want to define accuracy, how will you do it? First, define the denominator. What is denominator?
Predictions.
All the predictions. Out of
Yeah.
all the predictions, how many were correct? Right? This is denominator, this is numerator. Out of all the predictions, how many were actually correct? That is accuracy. So here, accuracy is nothing but true positive plus true
False
negative,
positive. True negative. Yes.
by sum of all.
All.
Okay. Is it
60%.
correct? Is it correct?
Yes.
Okay. So I can tell you one thing. If you listen to this lecture, you will know classification your confidence in classification will improve a lot. Okay. Most of the campus interview questions, most of the exam questions we will cover today. Okay. You guys are special because you joined my live session. So therefore you will get that incentive. Okay. Next is, what is precision? So whenever somebody asks you about precision, you have to ask, are we talking about the positive class or the negative class? The precision for positive class is different. The precision for negative class is different. Okay. So if you look at the positive class, what is positive class here?
True positive.
True positive. No?
No. So positive class is pass here. Negative class is fail here. So precision of people passing positive class. So again, there are multiple ways. Let us look at this way: TP by TP plus FP. Okay. So how will you define predictions? How will you define precision of positive class? What is the denominator?
True positive plus false positive.
Okay. Out of all the positive predictions, how many were actually true
True.
positive?
Yeah.
Out of all the positive predictions, how many were actually positive? This is precision. Similarly, what is recall of the positive class? The formula is TP by TP plus Fn. Okay. So how do you define this? TP plus Fn. What is this?
True positive plus false negative.
What does this mean?
Mm,
Out of all the positives, how many were actually predicted by the model correctly? Okay. So TP
Okay.
plus Fn. So these are the actual positives. Out of the actual positives, how much did the model predict correctly? That is recall. Remember these two formula. This is for the positive class. If you go to the negative class, precision, by the way, this is also called sensitivity. The other name for recall is sensitivity
Sensitive.
or true positive rate, right? These are used interchangeably. Precision of negative class. There is another formula, Tn by Tn plus Fn.
TP. Sorry, FN. Yes.
Next is precision, okay, recall of the negative class. This is Tn by Tn plus Fp. This is also called specificity. It is also called false positive rate. Okay. So if somebody says calculate the specificity, you should know that we are talking about negative class. If somebody says sensitivity, you should understand they are talking
Positive.
about positive class. Okay, is it clear?
Yes.
Okay, so there are two classes in this problem, positive and negative. Sensitivity refers to the positive class, specificity refers to the negative class, and these are the formulas, and you know how to define them. First, write the formula and then talk about the denominator, then talk about the numerator. Right? I will send this Excel to you after the class. Then go through the Excel, and then you should be able to understand what is happening. This is true negative. Okay. So let us also calculate precision of the positive class. What is this? True positive divided by true positive
How
plus
many
false
false
positive.
positive?
Okay. This is true positive by true positive plus false
Negative.
negative. Okay. Next, what is the formula here? True negative,
Divided by true
true,
positive plus
true,
false positive.
true negative plus false
Acha, true
negative.
negative. Acha, we are doing for precision of false, right?
Yes, yes, yes.
Oh, okay, okay.
True negative divided by true negative plus false positive.
False negative, false positive.
Okay. So when somebody gives you actual and predicted values, you should be able to create a confusion matrix. Right? This is not the actual confusion matrix, but something that is easy for calculation, right? And then from that you can calculate accuracy, precision, true positive rate, precision of the negative class, recall, right? Any, we can use the names interchangeably. I might ask you calculate the specificity, calculate the sensitivity, calculate true positive rate, calculate false positive rate, and so on. Okay, you should be
Okay.
in a position to do all these things. This is one type of question that is very common in interviews, that is common in exams, and so on. Okay, so now let us understand classification in more detail, especially the logistic regression model. Okay, why do you need logistic regression? Why can't you do modeling with regression, right? You know, the target variable has to be probabilities, right? So we can have a threshold like 0.4 or 0.5. anything above 0.4 can be positive class, anything below 0.4 can be negative class. Can we have this kind of a setting? Why do we need logistic regression?
To actually have some predict like to predict something for a classification problem, right?
Hmm.
So we can use logistic regression for this.
That is what why, because uh, actual regression, right? When you use linear regression, right, your probabilities may not be between 0 to 1, right? This is not possible.
Okay.
It can go below 0, it can go above 1. So therefore, you need an activation function like sigmoid to make sure that your probabilities lie between 0 to 1. That is why you need this sigmoid function. You've seen this S curve, right? So you can have a threshold and so on, right? It will be 0 to 1.
One.
Okay. So that's why you need this sigmoid curve. So 1 by 1 plus e power minus z. What is this z? What is this z? 1 by 1 plus e power minus z. This is the same linear regression z. Y is equal to beta naught plus beta 1 into x1, beta 2 into x2. So here I have a very trivial data set. Ignore this customer ID because it is unique. It does not add any value. You have two features, x1 and x2. And I have built a logistic regression model and I have estimated my coefficients beta naught, beta 1 and beta 2. This is my beta naught, beta 1, beta 2. I have a threshold of 0.4. So what is your linear regression model? Y is equal to beta naught plus beta 1 into x1 plus beta 2 into
Two. X2.
x2.
X1. X2 or X1?
x2.
X1. X2.
Okay. So if you look at the formula, let us do the referencing that we learned in BDM. So if you press F4, this will be referenced. This will be referenced. This will also be referenced. Okay. Now if I drag this, I'm going to get it for, right. So I explained about linear regression, right? You are getting values that are greater than 1 and lesser than 0, right? Can you see this?
Yes.
So that is why we need something like an sigmoid function that we saw here, right? 1 by 1 plus e power minus z. So now if I do this, 1 divided by 1 plus e power minus z, how much I'm getting? 0.65. Right? These are my probabilities. Do you see this is between 0 to 1? Do you see anything below 0? Do you see anything above 1?
No.
That is because sigmoid function will make sure that the output variable will lie between 0 to 1, greater than 0 and less than 1. Is it clear? So
Yes, sir.
now, how will you say these are the probabilities? How will you say whether this is class 0 or class 1? You need something called a threshold. What is this threshold? Anything above the threshold will be called as class 1. Anything below the threshold will be called as class 0.
Negative. Plus
So what
zero.
is this? What is this? Class 1. This is class 0. Class 1, class 0, class 1, class 0.
No, sir,
Let,
class zero, I guess.
okay, let us do a simple if statement. If
No,
it is
class 0 and class 1 means, sorry, I missed it. Is it
okay,
pass or fail, or is it like what do you
this
mean
is a
by class
different
0?
problem. This is a different problem.
Okay.
I'll tell you again. Okay, let us do this. I'll tell you again what we did. So that was a different problem. Pass or fail is a different problem. So this, we have two features, x1 and x2. And
Mm.
for these two features, I've already built a logistic regression model
Mm.
and I have estimated these betas. What is this? Beta naught, beta 1, beta 2? These are the coefficients of the logistic regression model, right? So when you have features and then when you have the coefficients, can you predict your target variable, whether it is 0 or 1? The answer is yes. How you will do it? First, you calculate this z, which is like a regular linear regression model. And then you calculate the probabilities using sigmoid function. How are you doing this? Using the sigmoid function that we saw here, 1 by 1 plus e power minus z. When you do this, you get probabilities, and then you have a threshold. Anything that is greater than the threshold will be called as class 1. Anything that is lesser than the threshold will be called as 0. Is it clear?
Yeah, clear. Yeah.
So now actual data, somebody might give you the actual data, right? Right. So when you have actual and prediction, can you call it as, can you tag it as false positive, false negative, true positive, true negative, and then you can calculate accuracy, precision, recall? Is it possible?
Yes.
Good. That is what we want. Okay. So now, is it okay? Is it complicated? Is it understandable so far? What I will do is I will share this sheet after our class. Right. This will be sent as a separate supplementary material. You can go through the sheet, and if you have any doubts, we can discuss in the next class. Is it fine?
Okay.
Okay. So now we are going from binary class to a multi-class. What is a multi-class?
More than two variables are involved.
When it is called levels, right? If you are your target variable y variable, it has something like spam, not spam. There are only two levels, right? But if you have more than two levels, right? So 1, 2, 3, these are the levels. When you have more than two levels, it comes under the category of multi-class problem. Okay. You can have 3, you can have 4, right? You might need more sophisticated activation functions, something like softmax, right? These is outside this, I mean, outside the scope of this business analytics course, but it is good to know this, right? When you have more than two classes, there are some brilliant activation functions like softmax. This could be used for predictions. Okay. So let's not go there, but it is good to know. So now we have a 3-class problem: urgent, normal, spam. Urgent, normal, spam. What is this? If you have something like this, predictions and actuals, and you have the classes present, and then you have the variables imputed, you have the urgent as 8. What type of setting is this called? What matrix is this? What matrix is this?
Con-
Confusion.
Confusion matter.
Why is this called confusion matrix? Because it is very confusing. Okay. So here you have the predictions, right? So these are your predictions. Actuals, these are your actuals. Is it clear? Actuals are here, right? The actual urgent. So 853. So there are, how many urgent classes are there? So there are 16. 16 in number. These are actually urgent. But how much did your model predict as urgent? 19. Is this clear?
Okay. Yeah.
The actual urgent were around 16, but your model predicted around 19 mails as urgent. Similarly, how many normal emails were actuals? 100.
100
But your model predicted 115 as normal.
normal.
Okay. So now what you have to do is, so is it very easy to compute something like this? TP by TP plus FP. This
Yes.
is this is actually possible for a binary classification problem. But now you
It's a
have,
multi-class.
so how do you do it? There are 3 classes. What is true positive here? What is true negative here? It is slightly tricky. There are many ways to do it. I am going to talk about only one method called micro averaging. Okay, it's a very standard way of doing multi-class problem. So now what are we going to do is, let us take one class, urgent. Okay, we are going to talk only about urgent class, and anything that is not urgent will be non-urgent. Okay,
Yes.
similarly we can talk about normal, right? Anything that is not normal, that is urgent and spam together, will be called not
Not
normal. Likewise, spam, right? So we will talk, we'll take one category as spam, the other two will be clubbed together as not spam.
not spam.
Okay, so that is what we are going to do. I'm going to take, first let us talk about urgent. So how many mails were actually urgent, right, and also predicted as urgent?
8.
8.
How many mails were urgent, right?
Yes.
And predicted as urgent, so it will be
Okay.
8.
How many emails were actually not urgent and predicted as not urgent? All these.
All
Okay.
these.
How much it is? 340. If you look at the sum, it is 340. Right? 340. So this is important, guys. Pay attention. If you have any doubts, we can discuss. Similarly, how many were actually urgent? Okay, let us talk about this. What is this? This combination?
Not urgent.
Think about it. It is predicted as urgent,
Urgent, but it
but
is not
actually not urgent. Predicted as urgent and actually
not
not
urgent.
urgent. So where will it come, here or here? Predicted as urgent, actually not urgent.
11. Yes.
Okay. Similarly, what is this?
Predicted as urgent, but it is not
No,
urgent.
no, no, no.
Acha,
Actually, it is urgent.
actually, it is urgent, but it was predicted not urgent.
Ah, so that will come here. This will be how much? 8.
8
This will be
and 11.
11. Okay. Okay. Can you try this normal? I will help you. Actually normal, predicted normal. How much it is?
Actually, normal and predicted normal is 60.
Yes. Actually, it is normal. Predicted as also normal. It is this intersection area, which is 60. Okay. Next one. Here, how much it is? These are
So this is
okay.
The
Not normal. Not normal.
not normal.
So it
the
is
other leaving the 60 remaining things, right? It's not normal.
So this is 5, 3, 50, 200. Acha,
8,
it's normal,
1,
right?
200,
8,
8
1,
200.
1
3, and 200.
200 3.
Yes. Okay. So it is 212.
Yes.
Okay. Similarly, if I populate this in the interest of time, let me do it, and then you can tell me whether it is correct or not, because we will spend a lot of time on this. And next one is 200. This is 55. This is 40. This is 83. Is it okay? Any confusion anywhere?
Its predicted spam is
Mm,
200, right?
mm,
And actually not spam, but predicted spam.
mm. This is
Yes,
how much?
it
83.
is. Yeah, this is predicted not spam, but actually spam.
Mm.
40.
Yes.
And this is actually not spam and predicted not spam.
Yes. Yes.
So
Okay.
this is, yeah.
Okay. Next one. So prediction is actual is also yes. How many you have like that? This one. I mean, now from prediction, urgent, normal, and spam, we are talking at the model level. That is for all three classes put together. Okay. So if you see all these
200.
things, if you see these three yellow shaded ones, they are actually yes, and prediction is also yes. So therefore, what will you will
268.
have? This plus this plus this. Okay. Similarly, this one, it is going to be this
340,
plus this.
212, and 83.
Okay. Okay. Similarly, this will be 99. This will also be 99.
88.
99. 8, 8. Oh, 88. Ah, okay. This is
Yes.
88. Okay. So now, if you calculate the accuracy, how it is? What is the accuracy formula? Now you have it in a binary formula, in a binary class. Yes, no. What is accuracy here?
True
This
positive plus
2 plus
false
2 negative
two
by
true
negative
total
negative.
number of predictions.
divided by total number of
Yes. Okay. It's around 83. Am I missing something? Are my numbers correct? I could be wrong. So be mindful of that. Looks okay to me. 60, 40, 55, 212, 811, 8340, 255, 40, 83. It looks okay to me. Okay. Okay. So this is how you will treat a multi-class problem.
Okay.
Is it fine? Is it fine?
Yeah, yeah.
Okay. So now your confidence on logistic regression is better.
Yes.
Okay.
yeah.
Okay. Then let us stop the live stream and discuss few things offline. So with this, officially the live session is over. We can stay for a
Thank you,
few
sir.
more minutes, and if needed, you have any doubts, we can talk about it. I'll stop the
Okay.
recording first.
Okay.
Then okay. So now I'm officially